Coming to you live, fifth period, physical science. We're going to describe the density of liquids lab, what you guys got for results. And then we'll also get started into the next activity with density of gases. Okay. So first, for the density of liquids activity. So last night, what you were supposed to have done was calculated the densities for each one of the A's, densities for each one of the W entries, and then taken an average. Did anyone do that last night? Okay? Alright, so what did you come out with for an average for the alcohol?
I got 5.79.
5.79?
Yeah.
Okay. Anyone, Danielle?
I got 6.59.
6 point what?
5.
For the alcohol, for the A?
There's an outlier, I think.
Okay.
Because someone had for the density to be 30 because they had for A, because there's a 3 and point.
I wonder if it has something to do with this right here.
Is that total going to be 30 as a density? Which
Yeah, it would.
And if you take that away, I got the density to be 0.948.
0.9 what?
48.
0.948.
Yeah.
Okay. Well, and I'm not certain about this. Maybe it's supposed to be 3 grams over a milliliter instead of a tenth of a milliliter. That does seem strange. Unless it's supposed to be 3/10 of a gram over a milliliter. I don't know. I'll tell you what, let's do some number playing around now. So 8.8 divided by 12 gives us 0.73. 34 divided by 15, pretty big number, 2 2/3. Actually, it's 2.2 and then 6 repeating.
Yeah, so I'll go 2.3.
Well, that seems like a big number too.
Yeah.
Okay. Yeah, 3 divided by 0.1 is 30. 20.7 divided by 26, 0.796. 30.5 divided by 31.25, 0.976. And the last one, 19.8 divided by 27, 0.73. Now, a question for you guys. When you did this activity, did you remember to take out the weight of the vial? Okay? That, because if not, that could be one of the issues here with these two numbers. But I tell you what I'm going to do, is I don't know for the two groups that did these what it would have been. I'm going to cross them out for now and just include these 1, 2, 3, 4 numbers that I have. So 0.733 plus 0.796 plus 0.733 plus 0.976 and divide by 4. I get an average when I do those 4 numbers, because again, these two seem to be some pretty big outliers. Thank you. I get an average around 0.810 grams per milliliter. And again, that's excluding those two numbers. Again, not knowing if people put in the decimal correctly or not, if you remember to take out the vial or not, etc. Okay. Now, for the W's, what did you come up with for an average for the W's?
I got 0.99.
0.99. Danielle, did you come out about the same?
Yeah, but I got 1.11.
Okay. So whether it's 0.99 or 1.11, actually this is pretty close. What would this round up to?
1.
1. Okay, so from your From your question that you had the other day from number 2, it says water has a density of 1 gram per milliliter. Or no, it asks what is the density of water. And we found out from what you guys are looking at that water has a density of 1 gram per milliliter. Okay, how do we know it's 1 gram per milliliter? Well, from what you guys just did with your data. You took a volume of water, obviously you measured what the volume was, and then you massed it. And then when you did mass divided by volume, it comes out to an average of about 1 gram per milliliter. It tells us that 1 gram of water has a volume of 1 milliliter. So 1 gram of water has a mass, or 1 gram of water has a volume of 1 milliliter. So yes, W is actually referring to water. And the A. Maybe I said it the other day, maybe not. What do you suppose A is referring to? Alcohol.
Rubbing alcohol.
Yep. It's rubbing alcohol.
Smelled it.
Yep. It has a very distinct smell, doesn't it? Yeah. So the A was actually referring to rubbing alcohol. Okay? Rubbing alcohol. Now, I believe your question from this lab had to deal with what is the relationship between mass and volume for a liquid. So what do we know that it is? What do we know is the relationship between mass and volume in general? What is mass divided by volume? Density. Yeah. So we proved with this that the relationship between the mass and volume of a liquid is the same as the relationship between the mass and volume of a solid. Okay? So whether it's a solid, whether it's a liquid, the relationship between mass and volume for either of those objects is still density. Okay? The relationship between those objects is density. Okay? So now then, with those numbers that you have from your lab, obviously you can do a brief journal write-up on that. So far in your journals, you should have that activity that we did, the mass and change activity. The beginning question dealt with the cookie crumbles. So there's one activity. And then this half of the unit we've had the, I believe we had the cube activity where you put together the cube. You did found the mass and volumes for them. Then we had the density of solid activity, and then this activity. One more coming at you, and that'll be density of gases. That's what we'll finish up with here. In your emails, as I mentioned previously, I sent it out first hour to that group, so once I sent it out, everyone should have gotten it. You should find in your email a reading on density. Again, that's the only reading that you'll have for this journal. So you have that reading, so you can start working on that reading section for your journal. Okay? So you can read up on it. We will take some time to discuss it on Monday. So part of your assignment over the weekend can be to read the email on the density article, or to read the article on density. Okay, and we'll discuss it on Monday. You can write up a blurb about it in your journals. All right. Now, so density of gases. Okay. So density of gases. Here's the question I'm going to throw out at you. How does the density of a gas compare to those of a liquid and solid. How does the density of a gas compare to those of a liquid and a solid? Anyone ever used this before? This stuff? Alka-Seltzer. No? They have Alka-Seltzer pills? Huh. But you've never used this stuff before? No? Oh.
I don't do this.
This may not be very effective, as what I've got crumbling around in the bottom here is old. But we'll see, just for kicks.
Yeah, it's not working.
No, not very well. Oh, it's starting to a little bit. It's going a little bit. What do you see it doing?
Fizzing.
Huh? Bubbling? Fizzing? What's that fizz or bubble? CO2, yeah. So it is CO2 gas. Yeah. So what we're going to have to do is obviously we want to find the density of this gas. And no, by finding the density, I don't just mean type on your computers and Google it, okay? I want you to experimentally figure out the density of this gas. Okay? So, what I'm going to do here shortly is we're going to put you guys into groups, of course, like we usually do. And in your groups, you're going to develop a procedure for how you're going to be able to collect the mass of the gas, and the volume of the gas. You've got to develop a procedure for how to collect it. Because without them, you can't do the calculation. Right now, obviously, I've got an open container. So it's not going to be very effective to collect a gas that way. So using the equipment I have in the room here, using the equipment I have in this classroom, you can explore around and figure out what we've got here that you can use to be able to collect that volume. Let's use a little more of an effective tablet. I'll use a half of one
Are
here.
you going to say water?
And I'll dump the water.
Yeah, if it wants it, please.
By the way, each of your groups is only going to be getting a half a tablet. You're not going to be getting a full tablet. And I will need to sign off on your procedure first before you can actually do it. So that way you're not going through tablet after tablet after tablet after tablet after tablet after tablet after tablet. In other words, you're not just going to be doing trial and error to figure out how you can do it. Okay? And I'll provide you with some help too, with some hints if you're having extreme difficulty. That's not a very good break, but now what the heck.
No, it's not looking very good either.
Let's see.
Whoa.
Oh, dear. You broke it.
Yeah, I did.
I can see something
And it's not a whole lot. But anyway, if I have a good active tablet, what should happen to some of this water? It should fizz over, yeah. It should fizz over. So keep that in mind. keep that in mind about how this will really work. Think of it as almost kind of like a can of pop. Like, you know, if you shake up a can of pop and then try to open it up. Okay? Because obviously that's CO2 gas in there too. So think about how dropping your half a tablet in here and then closing it off, think about what's going to happen to the wall. And keep that in mind. Right. So that is your task, and obviously we're not going to get to starting the experiment today, but at least I can get you guys into groups. Ready? Put your chair down, and you guys can start brainstorming your procedure for what you're going to do on Monday. Yes?
Oh, them or marbles?
The marbles. Okay? Excuse me, Brady. Need to shut off the camera because we are done for today.